Hello everyone, I'm Kaundinya. We are Team GitQ. We want to thank everyone for the opportunity to present today. And I'm very excited to present today a tool named GitQ, which is the result of the execution of our idea of displaying badges for repositories on GitHub. GitHub has become one of the most important sources of software artifacts on the internet. Looking at the numbers, currently GitHub is home to 44 million public repositories. Moreover, GitHub comes with a massive 63 million developer network. Researchers and developers mine a lot of information that is stored in the GitHub webpage, trying to understand a lot of details that a repository owns. Users contribute to GitHub repositories via code commits, pushes, pull requests, and raising issues. Now, most of the information above the repositories are text-based in the form of stars, forks, commits, and so on. Here comes an important question. Is there a way to reduce the search space for GitHub users to find repositories they want to work upon? GitHub. Through this paper, we made an attempt to address these questions with the idea of providing visual cues to GitHub users. So, what is GitQ? GitQ is a browser plugin. When added to a browser, GitQ shows visual badges for repositories on GitHub. This is how a badge looks in GitQ. GitQ augments GitHub with badges that deliver visual cues quantifying the project's architecture and maintenance. With GitQ, we also provide additional insights for the scores obtained for maintenance metrics. GitQ is aimed to effectively improve developers' experience while using GitHub and assist them to identify the right repository to fork and use or to contribute to. Taking a look into the source code metrics chosen, we have defined the source code metrics to include dependencies among files in the project, figure out number of inherited classes, number of overridden methods, and so on in the repository across all the files with .java extension. These metrics are based on the commonly used CK metrics defined to identify code quality for object-oriented languages. Moving on to the maintenance metrics we have defined, the first one is the portion of files impacted per commit. This is the average proportion of files changed per commit. This metric tells the impact of commit on file changes. If a project has more files changed per commit, then the project is less likely to have good code organization and backward compatibility. Every time a commit happens, most of the files in the repository have been affected. We also calculate the commit impact on the number of lines of code, and this is the second maintenance metric. The next one is the ratio of open bugs to resolved bug issues. A novice developer can choose to fork a project that has less number of unresolved bugs. Without any further delay, let's take a quick dive into using GitQ as a browser extension. Users have to first navigate to the repository and download the plugin. After downloading the plugin, users have to open Extensions tab in their browser and click on Load Unpacked and select the downloaded folder to load the plugin. The plugin is now loaded. Let's now open a GitHub project. When a user opens a GitHub project, GitQ initiates the project analysis by first downloading the repository in the remote server. It takes a while to download the repository depending on its size. All the metrics are computed parallelly in the server. These blinking dots on the badge will disappear as soon as the score is computed. Along with the badges, GitQ also provides additional insights for the 4 maintenance metrics based on the scores obtained. Let's hover on to an icon, in this case active authors rate. The red background around the text indicates that this repository has got a poor score for this metric. However, this repository has got a very good score for the core impact metric, and it is indicated by a green colored background. The red color corresponds to poor score, blue color for a good score, and green for an excellent score. We are now open for any questions.